Dear students, welcome back to the concept classes Matthew. I am AMK. Today I am going to discuss about electric flux and electric field lines. The expression that we can calculate the electric flux. Basically, this chapter is from class 12 physics, electrostatics. The topic is electric flux. Class 12. It is class 12. Electric flux. Simply, first we need to understand about the electric flux. Electric flux are what? What is electric flux? Hmm? Simply, electric flux are the imaginary lines that are start from positive charge and entered into a negative charge. Okay, but two electric field lines cannot intersect each other, and electric flux are electric field lines that are passes through normal of a surface that are passes through normal of a surface. Okay, now I am going to find out the expression for the electric flux. Before that, I am going to consider a surface of area delta S. Suppose students, here is a surface. Let us considering a surface. Suppose this surface is of area delta S. To obtain the electric flux, I need to draw a positive normal into the surface. Now, I will going to draw a positive normal to the surface. It is a positive normal, and and here is an electric field. Here is an electric field making an angle theta with the positive normal. Here is the electric field vector E making an angle theta with the positive normal. And again, I will have to consider a area vector delta S along the positive normal, right? And vector E electric field vector E makes an angle theta with positive normal. Now delta phi is the electric flux of the surface Now delta S will be delta phi. Students, delta phi will be given by delta phi will be given by dot product of vector E and area vector delta S, which is along positive normal. Okay, this gives E delta S cos theta. This is the amount of electric flux which is passes through this surface delta S. You can calculate the amount of electric flux which is passes through the surface delta S using by this formula, by this expression. Now students, I will have some condition, I will have some doubt, I will have some question regarding this expression. The question is, if electric flux is, suppose say this electric flux is parallel parallel this electric field is parallel to the positive normal, that is along the into the direction of area vector delta S. Okay, what will happen? Let us find out. Let us find out the condition. Students, condition 1. If electric if the angle between electric field and positive normal is 0 degree, that is direction of the electric field and positive normal is same, that is electric field is parallel to the area vector delta S. Now substituting from this expression, students observe this, from this expression E delta S into cos theta is equal to what? 0 degree. Cos 0 degree. This gives cos 0 degree is equal to 1, that is E delta S. It means amount of electric flux is passes through this surface is E delta S. Okay? Okay? When the electric field and the area vector is parallel to the surface, then amount of electric flux is passes through that surface is delta phi is equal to E delta S, as theta is equal to 0 degree. Okay. Now going into the next condition, if theta is equal to pi, that is the direction of the electric field is opposite to the direction of the area vector. Okay, opposite to the direction of the area vector, that is theta is equal to pi. Now delta phi is equal to E delta S into cos phi. Cos 180 degree is equal to minus 1, that is minus E delta S. the value of delta phi is equal to minus E delta S. Okay. Now into the, it is condition number 2, and into the condition number 3, again if theta is equal to pi by 2, that is, it means what? Theta is equal to pi by 2 means what? When the direction of the electric field is parallel to the direction of the surface, that is perpendicular to the direction of the area vector. Perpendicular to the direction of the area vector. In that case, electric flux will be E delta S into cos pi by 2. It means 0. The amount of electric flux is passes through the surface is 0 if the angle between the surface area and the electric field is 90 degree. Okay, students, we need to understand about the electric flux, electric field lines, okay, and the amount of electric flux in different condition. The amount of electric flux in different condition when the electric field line, direction of the electric field lines is parallel to the positive normal, and direction of the electric field lines is opposite to the positive normal, and the direction of the electric field is perpendicular to the positive normal. What will happen? I have already discussed all these details in this video. Okay, and I will discuss Gauss law of electrostatics in my next video. So stay with me, and I hope this video will help you to understand about electric flux and how to calculate electric flux of an surface. Okay, have a good day.